everybody, this video is going to be on Chapter 7 Coordinate Geometry. In particular, it will be about 7.3 midpoint of a line segment. The objective of this section is to find the midpoint of a line segment, use the midpoint of a line segment to find the equation of the perpendicular bisector of the line, and also to solve problems involving the midpoint of a line segment. In this video, we will only be covering the first objective. So what exactly is a midpoint? A midpoint is found on the line segment and it divides the line segment into two equal parts. So what this means is that if I have a line segment AB, the midpoint will be the point that is right in the center, and it will create AM to be equal to the length MB. Okay, so M is going to be what we call the midpoint. To find the coordinates of this midpoint, we will rely on the coordinates of A and B, which are the endpoints of the particular line segment. And the formula to find that midpoint, the coordinates of the midpoint, will be requiring this. That will be the sum of the x coordinates, and we divide that by 2, as well as the sum of the y coordinates, and we divide it by 2. Let us first take a look at try 7 to practice using this midpoint formula. In this question, it shows you a diagram with a triangle ABC that has vertices A, B, and C. And then the points X, Y, and Z are actually the midpoints of AB, BC, and AC respectively. So in part I, we want to find the coordinates of X, Y, and Z. To find the coordinates of X by using the formula, so the formula that we covered earlier was x1 plus x2 over 2 and y1 plus y2 over 2. So to find the coordinates of x, which is found in the line segment AB, we will consider the x coordinates of A and B as well as the y coordinates of A and B. Hence, by applying that, we will get the coordinate 2.5, 3.5 for x. By the same theory, for finding the coordinates of y, we will be looking at the line segment BC, which means that we will use the x coordinates 5 and 1, as well as the y coordinates 5 and 6. So by applying the formula, we will also get 3 and 5.5. So by a similar method, we will find the coordinates of z to be 4.5 and 4. In part 2, we want to find out, we want to show that AC is equals to 2xy. So AC and xy are length, so we will proceed with finding out the length of AC, which is square root 17, and xy, which simplifies to be square root 17 over 2 by applying our laws that are rather the rules that we have learned in SERS. So what we see is that AC is actually 2 times of xy, okay, which is what we want to show. And lastly, in part 3, we want to show that AB is equals to 2yz and BC is equals to 2xz. So we will use the similar method to actually show that AB is equals to 2yz on the left and also BC is equals to 2xz on the right. I will leave the reading to yourself to learn. We will next move on to try 8, where we are given that the line y equals to x plus 1 intersects the curve y equals to x squared plus 2x minus 1 at the points A and B. We want to find the coordinates of the midpoint of A and B, which is called M. So if you need to, you may draw a diagram to illustrate the idea. So we understand that the curve is a quadratic one, so we will achieve a shape something like this, and the line y equals to x plus 1, something like that. So we will have the points A and B. It doesn't matter which one is A and which one is B, so long as they are intersections of the curve and the line. Okay, so what we want to find is to find out the midpoint M here. So in order to find the midpoint, we need to first determine the coordinates of A and B. And we will do so by solving the two equations simultaneously and achieve x equals to -2 or x equals to 1. Following from there, we find that y is -1 and y equals to 2 respectively. So these are the coordinates of A and B. Now that we have the coordinates of A and B, we will use the formula, the midpoint formula, to find the coordinates of M, which will eventually be -½ and ½ Next, we take a look at part 2, where we are told that D is the point 20 such that it is the midpoint of a line segment CM. Then we want to find the coordinates of C. Let us illustrate a diagram to understand this question. So we have a line segment CM, and we are told that D is the midpoint with the coordinates 20. We were already finding in part I the coordinates of M, which is -½ and ½ So we are left with finding out what is C. What we will do in this case is to first define C to be having the coordinates x, y. Then we will use the midpoint formula to relate C and M to D. So what this means is that we will achieve for the x coordinate of D to be achieved, we will achieve this equation, and based on the y coordinate of D, we will achieve this equation. Then we find that x is equals to 4½ and y is equals to -½ Therefore, answering the question, we will get the coordinates of C to be 4½ and -½ We will now take a look at try 9, which is the last question for this video. So in this question, it shows you a diagram that has a triangle with vertices A, B, and C. M and P are said to be midpoints of the line segments AB and AC. The line through MP meets the x-axis at the point Q. So in part I, we want to find the coordinates of M and P. So since M is the midpoint of B and A, we will use the midpoint formula and arrive at having 2, 6 as our coordinates of M. Whereas for P being the midpoint of A and C, we will also apply the formula and get 5, 2 as our answer for the midpoint. For the coordinates of P. Next, lastly in part 2, we want to find the ratio of MP is to PQ. It is very tricky to find this ratio because we do not have the coordinates of Q, which is found on the x-axis, and it is part of the extension of the line MP. So what we will do in this case, okay, we have already learned something similar, alright, in terms of finding ratio in the previous section. So what we will do is to draw right angle triangles that I have done so, where I have a blue one and a green one along the line MQ. So we will define x to be the point 2, 2. So we have the point x to be 2, 2, following the x coordinate of M and the y coordinate of P. And then we will have the y coordinate to be 5. And what about the y coordinate of y? Okay, it will be 0 because we know that Q is found on the x-axis. So because Q is found on the x-axis, the y coordinate of Q will be 0. So that is how I find y to be 5, 0. Now that I know what is x and y, we need to observe that MXP and PYQ are triangles that are similar to each other. So because they are similar, we will say that the ratio of MP over PQ, or rather the fraction, okay, is actually equal to MX over PY. So MX over PY are actually the vertical lengths MX and PY. And for vertical lengths, we will take the difference in the y coordinates, so we get the value to be equals to 2. Therefore, the answer for the ratio that we want will be 2:1. We can also use PX and QY, okay, to determine the ratio.